We're at AP Review. This is 2007 Form B, BC for response number 6. Let f be the function given by f of x equals 6 e to the negative x over 3 for all x. Part A, find the first four non-zero terms and the general term for the Taylor series of f about x equals 0. So this requires that you have memorized the e to the x Maclaurin series, right? So if you don't, you should totally memorize it, right? So e to the x equals 1 plus x squared over 2 factorial plus x to the n over n factorial, right? So you need to have that memorized, right? And the reason you need to have that memorized is because you're now going to put a 6 in front of it and then change the x's to the quantity negative x over 3. All right, so what that's going to look like is my f of x in part A. F of x is going to be a 6 in front of, right? And then my first term's still going to be a 1 because there's nowhere to plug in an x, right? The next term, instead of an x, I'm going to plug in a negative x over 3, right? The next term, instead of an x, I'm going to plug in a negative x over 3. That whole quantity will be squared over a 2 factorial, right? They said the first four non-zero terms, right? That's 3. So negative x over 3 quantity cubed over 3 factorial plus ... and I'm kind of running low on space, but we'll make it happen. Negative x over 3 to the n over n factorial plus ... right? And all of that's going to get a 6 distributed. So I should definitely clean this up, but that's the setup for what this looks like. So when I start to distribute the 6, right, my f of x is going to be a 6, right? The 6 times the negative x over 3 is going to end up being a negative 2x, right? Now this would have been a positive x squared, and then it's a 9 on the bottom, right, because the 3 is being squared, times the 2. So it would be an 18 on the bottom, right? But the 6 is going to cancel with that, so 6/18 is just going to give me a 3 on the bottom, so I'm going to get an x squared over 3, right? This guy, the 6 and the 3 factorial are actually the same numbers. They're just going to cancel. So I'm going to end up getting minus an x cubed over 27, right? Because the 6 and the 3 factorial will cancel, right? Plus ... Down the road, I'm going to end up with a 6, right? A negative 1 to the n, right? Because that's what I'm going to do to that negative on the x. An x to the n. And on the bottom, I'm going to have a 3 to the n and an n factorial, right? That's what my nth term is going to look like. And you do want to split that negative 1 from the x because it just makes life a little bit easier. All right, cool. So that's my first four terms and my general term for the Taylor series about x equals 0 for this f of x. All right. Part B. Let g be the function such that g is the integral from 0 to x of f of t dt. Find the first four non-zero terms and the general term of that Taylor series. Okay, so for g is just what happens if you integrate f, right? So g of x is the integral from 0 to x of f of t dt. They're telling you to integrate each term of this. Now notice that when you integrate them, they're all going to end up having a t, like if all of these had t's instead of x's. And so when you plug those zeros in, they're all going to go away. So fundamentally, all of the bottom terms that are being subtracted are all zeros anyway, so it's gone. So really, all they're asking you to do is integrate this term by term. So the 6 is going to become a 6t, but again, when I plug that top bound in, it's going to become a 6x, right? This is going to become minus a t squared, but that's going to be an x squared, right? This is going to become an x cubed over 9, right? So this is going to be an x cubed over 9, right? This guy's going to become an x to the 4th over 4 times 27. If you know 4 times 27 off the top of your head, that's great. If you don't, the AP is fine with you leaving it as a 4 times 27. So if you know that 4 times 27 is a 108, that's great. If you don't, leave it as a 4 times 27, that's fine. Plus ... and then the nth term, you're going to up the power by 1 and then divide by the new power. So what's going to end up happening is you're going to get this 6 and this negative 1 to the n are not going to change, right? It's going to become x to the n plus 1. And then on the bottom, you're going to have a 3 to the n. Now, interesting side note here. You could either write this as an n plus 1 times the n factorial, or you could recognize that an n plus 1 times an n factorial is actually an n plus 1 factorial. ... So that's what they want. I double check every time that I did exactly what they asked. They said write the first four non-zero terms, 1, 2, 3, 4, and the general term, which we did. On to part C. So we're given that h of x equals k times f prime of a of x, where a and k are constants, and we're given the Taylor series for h of x, which is exactly the Taylor series for e to the x, right? So what we can get from this piece of information right here is, oh, h of x is e to the x, right? So that's really what they want you to take away from that is, oh wait, hold on, I get it, e to the x is h of x, right? And they ask us to find a and k, right? So we know, so let's go back to what we know, right? We know that we were given at the start of the problem that f of x is a 6 e to the negative x over 3, right? So we could find f prime of x by doing the derivative of 6 e to the stuff, which would be 6 e to the stuff, times the derivative of the stuff, which would be a negative 1/3. So we end up getting that f prime of x is a negative 2 e to the negative x over 3, right? So negative 2 e to the negative x over 3, and I'll make that negative a little more obvious. Okay, so, and we then know that based on the definition here, that h of x is k times this thing, so negative 2k e to the negative x over 3. But we also know that based on the Taylor series we're given, that h of x is e to the x. So from that, we can make a couple of conclusions, right? Oh, sorry, e to the, sorry, my bad, negative ax over 3, my bad. That was f, because it's, sorry, I kind of skipped a step. F prime of ax would just be to put an a up there with the x, right? So negative 2e to the negative ax over 3, my bad, right? So so we know that negative 2k e to the negative ax over 3 is apparently equal to e to the x, right? So knowing that piece of information, right, we can figure out a couple things, right? The first thing we can figure out is that this thing must be equal to just an x. So negative a over 3 times x is apparently just equal to a 1 times x, which means negative a over 3 must be a 1, so a must be a negative 3, right? And the other thing we can ascertain from this is that the coefficient of this e to the x is a 1, so whatever this coefficient is, it must also be a 1. So negative 2k has to be 1, k has to be a negative 1/2. So this essentially hinged on you being able to derive f of x, right, and then plug in an ax instead of an x, and also being able to recognize that h of x is actually just the Taylor series for e to the x, and thus h of x is e to the x. And that's kind of it, and then you're matching what stuff is equal.